Welcome to this explainer. Today, we're going to break down exactly how you can master Argo CD and the whole GitOps philosophy in just 10 minutes. If you've been banging your head against the wall dealing with configuration drift, messy deployments, or you just want to know how modern platform teams are actually scaling their Kubernetes environments, well, you're absolutely in the right place. We're going to distill all the essential concepts into one clear, structured masterclass. Let's dive in.
We've got a packed agenda today. We'll be covering the GitOps revolution, Argo CD Architecture explained, core concepts and syncing, managing multiple clusters, and finally, best practices and troubleshooting.
Kicking things off with Section 1, the GitOps revolution.
Before we can really appreciate the solution, we've got to look at the chaos modern infrastructure teams deal with every single day. Picture this. It's 2 a.m., right? There's a live issue, and a totally well-meaning admin runs a manual kubectl edit command straight into your production cluster just to scale up some pods. So what actually just happened? Well, they instantly created massive, completely untraceable configuration drift. Your cluster literally no longer matches your code repository, meaning your very next automated deployment might just break the whole shebang.
And that right there is exactly where GitOps comes in as the ultimate law of the land. In this operational model, your Git repository isn't just a place to park your application code, it becomes the single absolute source of truth for your entire infrastructure. The golden rule here is so simple but ridiculously powerful. If a change isn't committed in Git, it simply shouldn't exist in your cluster, period.
To actually enforce this new law, we need a tool, and Argo CD acts as that enforcer. It's constantly out there comparing two critical things, the desired state, which is exactly what you declared in your Git repo, against the live state, which is what's actually running in your Kubernetes cluster right now. If those two things don't match up, Argo CD instantly raises the alarm.
All right, moving right along to Section 2, Argo CD Architecture explained.
Now that we've got the philosophy down, let's lift the hood and look at the actual engine running Argo CD. What's really fascinating here is where Argo CD lives. Unlike your traditional CI/CD pipelines that sit way outside your infrastructure and push changes in, Argo CD runs as a standalone continuous delivery app right inside your Kubernetes environment. It uses a pull-based model, constantly looking out at your Git repo and pulling that desired state inward. This makes the whole system so much more secure and reliable.
So how is this engine actually powered? Well, it relies on three main microservices. First up is the API server, and this handles all your requests, whether you're clicking around the web UI or using the CLI. Second is the repo server. This is the real workhorse, doing like 95% of the heavy lifting. It clones your Git manifests and cleverly caches them in a Redis database for 24 hours just to keep everything lightning fast. And finally, we've got the application controller, which actively monitors the live cluster to spot any of that configuration drift we talked about.
That brings us to Section 3, core concepts and syncing.
With the engine running, let's look at Argo CD's true superpowers, automated syncing and self-healing. When automated sync is flipped on, the flow is just beautifully simple. Step 1, you push a change to Git. Step 2, that application controller we just mentioned immediately spots the drift. Step 3, an auto-sync is triggered right then and there. And Step 4, your live state is instantly corrected to match Git. It's almost like magic. But you still have incredible control over how this syncing actually behaves. Enabling the self-heal policy is where the real magic happens. It instantly reverts any of those rogue manual edits we were stressing about earlier. Then there's the prune policy. If you delete a resource from Git, prune makes sure it gets deleted from your live cluster too, keeping everything nice and clean. And finally, allow empty is a fantastic safety net. It literally stops Argo CD from accidentally wiping out all your resources if a Git directory goes missing or gets misconfigured by mistake.
Next up, Section 4, managing multiple clusters. Look, once you master syncing one cluster, you're inevitably going to want to scale up. Argo CD is built heavily for the enterprise, so let's see how it handles massive fleets of clusters. The good news? You don't need a separate Argo CD setup for every single environment. You can actually run one single, centralized Argo CD instance, your main control plane, to manage and deploy to multiple target clusters simultaneously. This gives you a single pane of glass for dev, staging, and production.
To do this efficiently, we use a totally brilliant feature called application sets. You can think of this as an app of apps pattern. Instead of sitting there configuring 100 separate applications by hand, you just define a single parent template. By using a Git or cluster generator, this one template dynamically spins up hundreds of child applications across all your various cluster environments automatically. It's a real game changer. And this number right here brilliantly illustrates the real-world impact. Implementing this centralized GitOps approach with application sets can reduce your multi-cluster deployment time by a staggering 83%. It quite literally turns 30-minute error-prone manual chores into a 5-minute fully automated breeze. Just think about how much time that saves your team over a year.
Finally, we arrive at Section 5, Best Practices and Troubleshooting.
Before you rush off to deploy, let's do a quick reality check. Even the very best tools need to be operated correctly, right? So, here are some absolutely crucial best practices. First off, always start new migrations with your sync policy set to manual. This lets you safely preview differences before ArgoCD just takes the wheel. Second, and I can't stress this enough, resist the urge to edit configurations directly in the ArgoCD UI. Doing that totally defeats the whole purpose of GitOps. Keep your changes in Git. Also, for production, make sure you run Argo in high availability mode spread across at least 3 nodes to handle those anti-affinity rules.
Now, here is a very common and super frustrating pitfall. Imagine you've got a horizontal pod autoscaler trying to scale up your pods based on traffic, but ArgoCD sees that the replica count doesn't match what's in Git, so it forces the pods right back down. It's this continuous tug-of-war that will absolutely spike your CPU usage. But the fix is super simple. Just use the Ignore Differences feature on the replica field so ArgoCD knows to trust your autoscaler to do its job.
If your sync ever gets stuck or throws a degraded health status, you can use this quick troubleshooting matrix. If a deployment fails, your first stop should be checking your pod logs or your resource limits. If a service isn't routing, it almost always means your labels just don't match your pods. And if a persistent volume claim is stuck pending, double-check that your storage class is actually available in that specific cluster.
By strictly following these practices, relying on Git as your absolute single source of truth, and letting ArgoCD do the heavy lifting, you ensure that this continuous, declarative, self-healing loop between your code and your infrastructure stays perfectly in sync.
Now that you've seen exactly how powerfully ArgoCD enforces your desired state in just 10 minutes, you really have to ask yourself a critical question. Is your current pipeline actually keeping your production environment safe from drift, or are you just one manual edit away from total chaos? Take these GitOps principles back to your team and start making your infrastructure exactly as reliable as your code. Thanks so much for joining me on this explainer, and I'll see you in the next one.